Okay, so let's start with recapping what we've learned so far. With sine theta, if we have an equation like sine theta equals k, to find the principal value we can put that into a calculator and do the inverse sine of k, and that will get our principal value theta 1. To generate the second value, we do 180 take away theta 1, and we then add or subtract three multiples of 360 to theta 1, theta 2 to generate more values. Why do we do 180? Well, if we go back to the sine curve and we can see, say that's 360, that's 180. We know if one of our solutions lies here, say let's call that theta 1, then the other solution by symmetry is theta 2, and that's why we do 180. Now with the cos theta it works in the same way. We have cos theta equals k. To find the principal value we plug that into a calculator, and this time we do 360 as opposed to 180. That gives us our second value. Again, if we go back to the curve of cos theta, and that's 360, we know if one of the values, say that was theta 1, then theta 2 by symmetry would be here, and since that's 360 we subtract theta 1 from it. And again we add or subtract multiples of 360 to generate further values. With tan theta it works in the same way. Similarly, we also have theta 1, which we can then substitute into a calculator and generate a principal value. And then to generate a further values, we just add or subtract multiples of 180. And if we go back to the shape of the curve, we can see how that works as well, and how we get further values through adding or subtracting 180. Okay, so I'm going to run through a few examples and then give you two exercises to do. The first example that I'm going to run through is one where you've got tan squared theta minus tan theta equals 2, and the interval that we want is between 0 and 360. Right, we can start off by bringing everything over to one side. So we've got tan squared theta minus tan theta take away 2 equals 0. If you want, and to make it less daunting, you can say let tan theta equals x, and then we can rewrite our top equation as x squared minus x take away 2 equals 0. We can now factorize this, and so we're looking at factors of minus 2 which add up to give us minus 1. So we've got x minus 2, x plus 1 equals 0. This will then lead to two solutions. We have x equals 2 or x equals 1. If we go back to tan theta, since x equals tan theta, we can say tan theta equals 2 or tan theta equals 1. So that's minus 1. Right, so with the tan theta equals 2, if we put that into our calculator, our principal value should give us 63.4. We can then add 180 to it, and we should get 243.4. With tan theta equals minus 1, our theta equals minus 45. That's what we get in the calculator, but we also know that minus 45 is outside our range, and so we can add 180 to this, and that will give us our third value, which would give us 135, and we can generate another value by adding 180 to this with theta 3, and that should give us 315. So therefore our theta equals 63.4 or 135, 243.4, and finally 315. Right, it may be worth illustrating our results on the graph. So we know when tan theta equals 2, we've got 63.4, and then we added another 180 to it. That gives us theta 2, theta 1, and then 63.4, that gives us 243.4. And then anything above that, another 180 would be outside our range. when tan theta was minus 1, we got minus 45, which is here. We added 180, and we got our theta 3. Added another 180, and we got theta 4. Right, the second example that I'd like to do is one in which we have sine squared theta and a cos theta. And what we want to do immediately is to bring everything down to either sines or cos. So we know there's two identities we know. We know that sine theta over cos theta equals tan theta. But we also know sine squared theta plus cos squared theta equals 1. I can therefore rearrange this. So instead of writing 2 sine squared theta, I can write 2 1 minus cos squared theta, and that's from this identity here, equals cos theta plus 1. If we expand this out and bring everything over to one side, you may want to pause the video now and try that yourself. We will have 2 minus 2 cos squared theta equals cos theta plus 1. And if we bring everything over to one side, let's have 0 equals 2 cos squared theta plus cos theta minus 1. Now at this stage we can say let x equals cos theta if you want, and so you get 2x squared plus x minus 1, which can then factorize into 2x minus 1 and x plus 1. This will then give us two solutions where x equals a half or x equals minus 1. For x equals a half, we have tan theta, sorry, my mistake, we have cos theta equals a half, and for x equals minus 1, we therefore have cos theta equals minus 1. For the cos theta equals half, if we then found our principal value using the calculator, or if we know the exact values, we know theta equals 60 degrees, or 360 take away 60 and give us 300 degrees. For the theta minus 1, we simply know that theta will give us 180 degrees. So we've got three solutions. We've got theta equals 60, 180, or 300 degrees. So we may want to visualize the results on a graph to make things a bit more clearer maybe. We know cos theta is a half, cos theta is minus 1. For half, our principal value, theta 1, was 60, and then to find the other value we do 360 take away 60, and that gives us theta 2. For minus 1, we get 180 degrees, and so therefore that's theta 3. Okay, so the third and final example I'd like to consider is one in which we don't have a theta by itself, but actually theta is multiplied by something or added or subtracted by a number. So here we've got 2 theta minus 35. Also our limits are from minus 180 all the way to 180. We can start just by simplifying the problem and by making x equals to 2 theta take away 35. So what we've got is sine of x equals to minus 1. However, if we do that, we've also got to change our limits from theta to x. So 2 theta will give us minus 360 to 360. 2 theta take away 35, which is x, will then give us minus 395 and 325. So we've simplified the problem by introducing x, and also therefore by changing our limits. So if you want, you can write x is greater than or equal to minus 395 or less than or equal to 325. Now if we put this in a calculator, our principal value of x will give us minus 90. 180 minus 90 would also give us another value of 270. if I add or subtract 360 to either one of these, I'll go outside my range of values. So both of these values should be fine. We can illustrate this on a graph as well to make things more clearer. So we've got minus 90 over here. 180 minus minus 90 gives us our 270 over here. And anything a 360 this way or the other way will take us beyond our regions. Now we know what x is. So we've got 2 theta minus 35. So I can write 2 theta minus 35 equals minus 90 or 270. What we now want is just basically rearrange for theta. So I'm just going to add 35 to both of my values. So 2 theta equals minus 55 or 305. And now we just need to divide it by 2 to get our values of theta. So we should get minus, say, 27.5 or 152.5. So we've got two values of theta. Okay, so here's two exercises. I'd like you to have a go at these before we continue. And so you've got to solve for theta between 0 and 360. You've got 2 cos squared theta minus 1 is 0. And then you've got another one where you've got sine squared is sine squared of theta minus 30 equals a half. So what you might want to do is pause the video and have a go at these, and then come back and look at the answers once you've completed it. Okay, welcome back. Let's go and have a attempt at the first one. So we've got 2 cos theta minus 1 is 0. Again, what you could do if you want to, you could just do the whole thing in terms of cos theta, but I'd like to simplify where I can. So I'm going to say let x equals to cos theta. And now my equation becomes 2x squared take away x take away 1 equals 0. If we factorize this, we should get something like 2x plus 1 and x minus 1 equals 0. And therefore x equals to minus a half, or x equals to 1. I can now substitute back in, so I've got cos theta equals to minus a half, or cos theta equals to 1. For cos theta minus a half, my principal value should be 120, and then my second value should be 240. For cos theta 1, I know for my cos graph there's 360. I know it hits the 1 at 2 points between 0 and 360. So we know theta 3 is 0 and theta 4 equals 360. So we have 4 solutions: 120, 240, 0 and 360. Okay, so let's have a go at this question here, part B. So we've got sine squared theta minus 30 equals half. And the first thing we could do is get rid of the square root sign. So we've got sine squared theta minus 30 equals 1 over 2. And if we get rid of the square root sign, we just get 1 over square root of 2. And we'll get two values, positive and negative. For the benefit of students who might want to sort of have things explained sort of step by step, what I'm going to do is make this into an x. So I've got sine x equals plus or minus 1 over square root of 2. But since it's a small number and you're not multiplying theta by anything, if you want to, you can sort of continue as theta minus 30 as well. Since we've changed theta to x, we've also got to change our limits, and so now our limits become minus 30 to 330. So we've taken 30 from both sides, since x equals theta minus 30. So now we've got two solutions. Let's investigate both of them. So we've got sine of x equals 1 over square root of 2. We also have sine of x equals minus 1 over square root of 2. If we got for the first one, our x1 should give us 45, and then 180 take away 45 should give us x2, which is 135. For the minus 1 over square root of 2, I'll just write down x. If we put that in a calculator, we should get minus 45. That's obviously not within our range, and so we could do 180 minus 45, and that will give us our third value, which is 225. And we can generate another value, which I call x4, by adding 360 to this one, and that will give us 315. We now need to do is just convert back to theta, and we know x equals theta minus 30, so we know what our x's are. We just need to add, therefore, theta, add 30 to all our x's. So we should have 45 plus 30, 75, 135 plus 30, 165, and then 255, and 345. So those are our four values.